In this video, I will explain the properties of wave motion. The properties of wave motion help us to understand and describe the wave. The terms we use are period, amplitude, frequency, velocity, and wavelength. These properties can be extracted from two different graphs. The first graph is the displacement time graph. The graph tracks the motion of a single particle over time. It shows how the displacement or position of that particle changes with respect to time. The displacement time graph is often used to illustrate number one, the amplitude, which is the maximum displacement from the particle's equilibrium or unperturbed position. And number two, the period, which is the time it takes for a particle to complete one cycle of oscillation. From the period, we can derive the frequency, which is the number of complete oscillation in 1 second. The frequency is the reciprocal of the period and is measured in hertz. 1 hertz is one complete oscillation in 1 second. The second graph is the displacement distance graph. This shows how the displacement of the wave varies with the distance along the direction of propagation at a particular instant of time. In the case of a transverse wave, you can think of it as taking a snapshot of the wave, or an instant of the physical wave frozen in time. The displacement distance graph gives us two pieces of information. The first one is, again, the amplitude. The second one is the wavelength of the wave. The wavelength is the distance between two adjacent crests, two adjacent troughs, or any two nearest distance in phase. Given these two graphs, we will be able to determine the final property, which is the velocity of the wave. The velocity of the wave is the distance the wave travels in a given amount of time. Since it takes one period to travel one wavelength, speed can be calculated as the ratio of wavelength to period, as illustrated in this slide. Let us use what we have learned so far to solve a problem. You are given a displacement distance graph and asked the following question. Number one, what is the wavelength? Number two, given that the period of the wave is 1 second, what is the frequency and its velocity? Number three, what will be the wavelength of the wave if its frequency is increased to 5 Hz with no change in velocity? Pause the video and work out the solution on your own. Play the video again when you're ready. What is the wavelength of the wave? Well, if you recall, the wavelength of the wave is the distance between two successive adjacent crests, or two successive or two successive or adjacent troughs, or the distance between two nearest points that are in phase. And the answer is 50 centimeters. In the second question, the period of the wave is given as 1 second. The frequency is calculated as the ratio of the period, and that gives you 1 Hertz. The velocity is the product of frequency and wavelength, and the answer is 0.5 meters per second. In the third question, you are asked what the wavelength would be if the frequency is increased to 5 Hz with no change in velocity. The wavelength is calculated as the ratio of the speed over speed to frequency, and that is given as 0.1 meters. Well, that concludes this section of properties of waves. Check out our other videos.